95% of the universe is, in fact, completely invisible. Everything we look at, everything we see, everything we know, it's just a tiny sliver of the grand cosmic picture. That enormous remainder is made up of two mysterious components we call dark matter and dark energy. Understanding these dark structures is one of the greatest challenges facing modern science. What stands before us is a cosmic detective story, still waiting to be solved. And it all begins with a fundamental puzzle that has been haunting astronomers for decades. When we look at the mathematics, we can see quite clearly that the stars and massive gas clouds inside galaxies simply don't possess enough gravitational pull to hold those enormous structures together. According to the laws of physics as we know them, these galaxies should have scattered into the void of space long ago. So why haven't they? Something, an invisible hand, is holding all of these cosmic islands together. Imagine the universe, just for a moment, as a vast crime scene. The evidence is scattered across every corner of space, yet there is no visible culprit. Even though we can't directly identify this invisible architect, we can detect its fingerprints, or more precisely, its gravitational fingerprints, in every corner of the universe. So why can't we see it directly? Because this structure doesn't interact with light in any way. It doesn't reflect it, it doesn't emit it, and it doesn't absorb it. Yet we can feel its presence with extraordinary force. Just like we can't see the wind, but we know it's there from the way it moves the branches of trees. Dark matter makes its presence known in the universe through its immense gravitational pull. When we study the movements of stars, and even of entire galaxies made up of billions of stars, we realize there is far more mass out there than what we can actually see. This invisible extra mass forces celestial bodies into unexpected orbital paths, as if locked into a hidden cosmic harmony. The scientific case for dark matter's existence was built slowly, over decades of accumulated observations and evidence. The story begins in the 1930s, when astronomer Fritz Zwicky noticed that the galaxies in the Coma cluster were moving far too fast to be held together by the visible mass present. It was the first concrete clue that something was missing from the cosmic accounting books. Then, years later, in the 1960s, Vera Rubin was in the field, and she uncovered what may be the most striking evidence for dark matter ever found. According to Rubin's observations, stars at the outer edges of galaxies were rotating just as fast as those near the center. This completely contradicted everything we had understood about physics up to that point. Her observations pointed to one inescapable conclusion. It was as though each galaxy was embedded inside a massive invisible halo filled with some unknown form of matter. That invisible structure was dark matter itself. But dark matter is not simply a theoretical number plugging a gap in our equations. It is the invisible, colossal architect of the universe itself. In truth, 95% of the universe is a complete mystery to us. Of this enormous pie, roughly 27% consists of that invisible glue holding galaxies together, dark matter. The remaining 68%, the lion's share, belongs to dark energy, which is relentlessly pushing the universe apart. And what about us? Everything we see, everything we touch, everything we know, the stars, the planets, the nebulae, even ourselves, and all the people we love, all of this amounts to just 5% of the entire cosmos. We are like tiny foam bubbles on the surface of a vast ocean. Try to imagine how enormous a portion of the grand picture lies beyond the reach of human perception. So, what exactly is dark matter? For now, the best definition science can offer is built on what it is not. Dark matter emits no light, reflects none, and absorbs none. It is entirely invisible to light. If you shone the most powerful light source directly at it, that light would pass straight through as if nothing were there. Even though its existence is transparent, the name dark matter captures the deep mystery it harbors far more truthfully. The most vital role dark matter plays in the universe is that of a skeleton, an intricate scaffolding that has woven the large-scale cosmic structure, stitch by stitch. In the early universe, gravity spun an enormous invisible cosmic web. The ordinary, visible matter we know then answered gravity's call and gathered upon this vast skeleton. Like dewdrops collecting on a spider's web, the cosmic web we observe today, those magnificent filaments packed with galaxy clusters, with vast voids stretching between them, took shape in exactly this way. One thing is crystal clear. Without dark matter, neither those breathtaking galaxies nor we ourselves could ever have existed. But the story doesn't end here, with matter holding the universe together. At precisely this point, a second, unexpected, and far more mysterious force enters the cosmic scenario, a rival working relentlessly against dark matter. Since the very dawn of time, a silent and titanic battle has been raging over the ultimate fate of the universe. While dark matter uses its gravitational pull to draw everything together, this new force has the opposite goal. It is trying to push everything apart, galaxies, the very fabric of space itself. Astronomers came to realize this staggering truth when they discovered that the rate at which the universe was expanding was not slowing down over time, but was instead accelerating. It was as if some invisible force had its foot pressed all the way down on the universe's accelerator pedal. Two enormous dark forces stand before us, and together they create the great creative and destructive tension at the very heart of the universe. On one side is dark matter, the cosmic builder. It gathers matter through gravity and constructs galaxies. On the other side is dark energy, the destroyer by nature. Woven into the most fundamental fabric of space is an invisible and unstoppable force pushing everything apart. One is building the universe, while the other is tearing it all asunder. But what exactly is dark energy? This is where science finds itself most helpless. The honest truth is, we don't know what dark energy is. Dark energy is essentially a technical name we've given to our ignorance in astrophysics. It fills a colossal gap in our understanding of the cosmos. It may be an intrinsic form of energy that empty space itself possesses. But for now, that remains one of our most favored guesses. This relentless cosmic war between dark matter and dark energy is not merely a theoretical debate in physics. This struggle will determine the ultimate fate of the universe, of everything that exists. For the first 9 billion years of the universe, dark matter was the undisputed champion. Gravity was dominant. Dark matter was gathering matter together, building galaxies and enormous clusters. But approximately 5 billion years ago, a cosmic turning point occurred when the universe had expanded enough to reach a sufficient volume. As matter grew increasingly distant from itself, dark matter's gravitational grip weakened, and dark energy's unstoppable repulsive force stepped onto the stage. From that moment on, the control of the universe's destiny passed entirely to dark energy. The outcome of this titanic battle will determine how the universe draws its final curtain. Physicists currently have 3 main scenarios on the table. The first is the Big Freeze. The universe expands forever into the future. The last glowing star exhausts its fuel and goes dark, leaving behind nothing but a freezing, lightless, lifeless void. The second scenario is far more violent. The Big Rip. Dark energy accelerates and grows so powerful that it first tears apart massive galaxy clusters, then star systems, then planets, and ultimately rips apart every single atom in the universe. Or perhaps everything is simply an eternal cycle. According to the third scenario, the Big Bounce, the universe will at some point halt its expansion, collapse back upon itself, and trigger a new Big Bang, restarting everything from scratch. As we can see, this cosmic detective story at the heart of the universe is still very far from being solved. The true identity of dark matter and the dark destiny toward which dark energy is steering us, these remain the deepest, most fundamental, and perhaps the most unsettling questions facing science, still guarding their mystery. Scientists continue to analyze the list of cosmic suspects. We have a few strong candidates for the nature of dark matter: theorized heavy but weakly interacting particles known as WIMPs, or incredibly light hypothetical quantum particles called axions. Even primordial black holes, potentially formed in the first seconds after the Big Bang, appear on this list. But for now, they are all just mathematical theories. We have no concrete evidence yet to illuminate this mystery. When we truly sit with it, the picture that confronts us is genuinely staggering. We have absolutely no idea what 95% of the universe we live in is actually made of. This dark reality is both a humbling reminder of how small a place we occupy in the cosmos, and a breathtaking signal of how much still remains to be discovered. Every step taken toward the dark unknown continues to be the greatest adventure in the history of humanity. And this epic journey leaves our minds face to face with that one ultimate question: will we ever truly be able to illuminate the dark face of the universe? If you enjoyed this video, don't forget to subscribe, turn on notifications, and support us with your likes and comments. See you in the next episode. Take care.